The expectation of our designs to have wireless capability continues to crescendo in the embedded industry. Engineers continue to build strong knowledge of designing wireless products for general communication, but now that communication is getting more complex with needs for indoor location, mesh networking, and precise object tracking. What new tools are available for us to make these wireless applications easier to implement? Wireless radios really have become as ubiquitous today as serial ports were 20 years ago. It's just expected in the device that we design that you don't have to actually plug something into it, but it's just going to connect to the device around it, communicate, and be able to be interfaced by the user through that wireless technology. But as wireless technology is involved, we're starting to see it as a lot more than just a communication standard, and we're expecting our wireless radios to do more. We're looking at things like using BLE in order to do geolocation of objects inside of buildings and kind of replace GPS when we don't have access to the sky. We're looking at our devices that aren't necessarily network devices, but with an expectation that they can communicate from device to device to device to device to communicate with devices far, far away outside of their wireless range and get data from one point to another. With all of that comes a lot of new challenges for us as engineers who are designing wireless applications, and it's really something that's, I think, something we've all got to learn a little bit more about. Today I've got the privilege of speaking with Matthew Rose, Senior FAE for Panasonic, and someone who's spent a lot of time with engineers, teaching them and working with them on all of these new wireless applications. Matt, thanks so much for joining me today. Really appreciate your time on The Current.
Thank you, Todd. It's a pleasure to be here.
Yeah, absolutely. Absolutely. So, we're going to go into a couple of the new areas where wireless is being used today. But, first let's start with what's not necessarily new, but has always been kind of a challenge in wireless design, and that's mesh networking that I just kind of referenced. What kind of applications are you seeing today where there's a real need for mesh?
Todd, there are a number of mesh protocols, so 802.15.4 based protocols, BLE flood mesh, and each of them has an area where they do well in. Typically, mesh has been used in lighting applications, and I think engineers and program managers are starting to kind of spread out and think a little bit more about where these mesh nodes can be operated and be successful. So thinking of different applications for mesh. I'm here at a trade show this week, so temporary or permanent occupancy detection is a new application we're seeing. So setting up nodes throughout, say, a conference center, using either temp, humidity, PIR sensors, perhaps even low bandwidth cameras to monitor, provide security, temporary security in these types of applications as well. Another type of application that we're seeing mesh starting to get rolled out is for sensor networks, say for monitoring cold goods and storage. So say in a refrigerated warehouse where you might want to measure temperature throughout, say, a 5,000, 10,000, 20,000 square foot warehouse. And so providing temp sensors in a mesh network to pass that data back to a centralized location. Another interesting application is using these nodes as input. So we're actually working with a third party right now to develop a fun game as a promotional tool that has multiple inputs, say joysticks or controllers. And instead of using a standard connection, you could use a mesh network as a input and control type of situation.
Okay, interesting. And I think it's something that can go so many different directions. We're seeing so many unique utilizations of mesh networking. It's a lot of fun to watch. I know, years ago, probably now 15, 16 years ago, I was trying to do a mesh network with just a standard 802.15.4 radio. I really kind of wrote the underlying protocol and how the communication scheme was going and how the devices would all hook up into the network. And man, I got to tell you, it was absolute agony to go through that process and write all of that code and kind of figure it out. What are some of the tools today that are making that a lot easier for engineers to have probably a much more stable and also certainly easier to implement mesh network than what I did all those years ago?
So with regards to implementation and prototyping mesh networks, we've definitely come a long way. They're not along with Zigbee, there are other 802.15.4 types of protocols like Thread and HomeKit, where a lot of template code has been created. So you can engineers can definitely be further along in the prototyping stage. Also with new protocols like Matter, which is what I would call an intermediary protocol that helps to tie in other protocols. Specifically, in this case, the leading application seems to be home networking with Matter. So you're basically interconnecting Wi-Fi, Thread, BLE, and even cellular networks so that there is a centralized overall protocol, say an application level protocol that allows these different protocols to speak well together, so that you can not necessarily have a single manufacturer throughout your home, but have multiple manufacturers all talking on a network.
Right, right. And that definitely exciting where that's going to take things and the possibilities there of being able to blend that 802.15.4 and Wi-Fi and also Bluetooth all together and make that something that's much easier for the user experience. I think we've seen a lot of the big cell phone manufacturer companies and things like that have also announced the capabilities of having 802.15.4 radios in their phones, which hopefully is going to, I assume, play into the adoption of Matter is certainly something that I'm hoping that we're going to see. I also hear about standards like Wirepass is something that's part of that as well. Between all of those, where do you see the benefits? And talk to me a little bit about kind of where Wirepass plays, Matter plays, and all of that kind of thing.
So Wirepass is a corporation based out of Finland. We do have a relationship with Wirepass to support either their proprietary protocol or 802.15.4 based protocols on our PAN 1780 module, which is based on the Nordic NRF 52840 device. Sure. Wirepass has a lot of application for mesh networking where you normally wouldn't think that they'd be successful. So they have hundreds and thousands of nodes in some of their installations in Europe. So we've worked with Wirepass to develop a dev kit that has 4 nodes and a central coordinator node. And the application code is set up for a occupancy detection type of application. So it has temp sensors, ability to have a PIR sensor, has RGB lighting and a switch input. So if somebody was interested in getting a start on a prototype for an occupancy type of system, or even, as I mentioned before, a monitoring temperature type of system or application, then they've got a head start there. Another interesting application, being from Denver and having, shall we say, some new agricultural markets open up, is indoor agriculture. So you can definitely use mesh networks, whether it's a Wirepass type of network, a Thread, and Matter type of network, to monitor temperature, humidity, lighting throughout the day, change lighting for different growth cycles, and basically implement, whether it's at a professional type of level or even at a home level, these types of indoor agricultural monitoring systems.
Right. Very nice. Very nice. See, and I think all of that makes it just so much easier. I think when you've got a partner like Wirepass that you can go to and have them help you out with how to form that mesh network and give you a lot of the firmware required to make that happen, it definitely makes life a lot easier for those kinds of designs. So let's step away from mesh a little bit and let's talk about the other application I'm seeing a lot of. We've all got cell phones, we've all got Bluetooth radios and so many different things, and we're seeing where BLE, Bluetooth Low Energy, is starting to get into having the capability of being able to locate objects within a building. If you've got the Bluetooth radio, you can actually locate the device with the Bluetooth radio and it using angle of arrival or angle of departure. I'll be honest, from what I've seen with some of that, I've been a little underwhelmed so far. Just the accuracy of it, and maybe I just haven't seen some of the better demos out there, but it seems to be pretty good, but a little bit buggy. What are some of the things that you're seeing helping engineers to implement AOA or AOD in their BLE designs going forward?
So I want to take a step back and say that the Bluetooth SIG, the Special Interest Group, has identified 4 use cases for BLE. The first is general data management. The second is mesh networking. The third is asset tracking. And the fourth is BLE audio. And so we've worked at Panasonic to develop relationships for mesh networking, asset tracking, and BLE audio. And we just recently spoke about Wirepass and their partner Symbiotech out of Europe that we've worked on this dev kit. We've developed a partnership with a company out of Southern California called IOSEA, and that's IOSEA. And they have two PhD antenna folks as their leadership core, and they have developed some state-of-the-art antennas for tracking, asset tracking. And so we've worked with them and Future to develop a kit, promotional kit we call the Dragon Kit, and we have rolled this out to many of the FAEs at Future. And basically, the Dragon Kit comes with a locator, which we call the Argus locator, and a tag, which we call the Jaguar tag. And the tag has the ability to do asset tracking and beaconing, but it also is a sensor platform. So on this demonstration, we have a temp sensor and an accelerometer. So there's a number of different applications that we have bandied about and talked about for this. One, again, warehouse monitoring, so tracking pallets, temperature, has the pallet been shocked or vibed in some way, tracking residents of senior centers, checking their health. Looking at another application is using this technology for either construction site management, so being able to track the workers, the tools, vehicles coming on and off the site, as well as public safety officers, whether that's firefighters or police officers on an incident site. So setting up a temporary basically asset tracking system. So you could have any number of locators. The software from IOC is very easy to scale, and frankly, any number of tags. So they have examples of applications where they have hundreds of locators and thousands of tags. So setting up temporary or permanent installations for asset tracking is now easier than before. You had mentioned about accuracy. There's sub-meter accuracy that's available. Yeah. Just really depends on the application. How fast do you want to track something? But there are definitely a number of knobs and levers and parameters that can be set in order to affect the accuracy of what you're wanting to track. But we're very excited about this project that we've been working on with Future the last year or so, and we're looking forward to continuing that into the future.
Yeah, I agree, and I hope it's something that is going to help. I think the antenna design portion of that is so critical to that application working well, and so I'm hoping that's something that we can really help any engineers that are working on in those kinds of applications to get that right early on, because I think that's been the difference between what I've seen has not worked all that well and what I believe is going to work well with this Dragon design. I think the other thing you mentioned, the IOC engagement. And just being able to use them for that implementation, that helps a tremendous amount.
Yeah. So IOC is a smaller company, but they are somebody that works with customers and can help to develop custom designs, whether that's from the antenna side or the tag side, right. Or we actually do have some off-the-shelf solutions that are available for customers that just want to get a feel to see if this technology is going to work for their applications. So we do have some off-the-shelf stuff, and then we do have the capability to working closely with customers to custom design antennas or tags with them based around our PAN 1781, which is a Nordic NRF 52820 device, or frankly, any of the Nordic devices, depending on the application.
Right. Excellent. That's awesome. And then you already mentioned, my next question I wanted to talk about was, you mentioned one of the other applications that the Bluetooth SIG is looking at is adding Bluetooth low energy to audio applications. Talk to me a little bit about that. What's the opportunity there, and how's that coming so far?
So audio is an interesting ecosystem. Most of us non-engineers, so the people around us, have experience with classic Bluetooth audio in their day-to-day environments. So introducing a new audio protocol that shares the same name as Bluetooth is going to be a challenge for the special interest group, the SIG. We're kind of waiting to see how that's going to happen. They've branded it as Auracast, but they haven't really given it a revision number yet. So we're kind of waiting to see how the branding rollout is going to work to the general public, to the street, so to speak. The protocol itself is very interesting. It's very flexible. Similar how classic Bluetooth, it had its use cases, but it wasn't necessarily very flexible. BLE Audio is really designed to offer a flexible audio solution to a wide-ranging number of applications and customers. So there are, in essence, 4 different types of use cases. Excuse me. There is a broadcast use case. So that's where basically we have a single source broadcasting to any number of receivers. So really a repeat of Marconi radio, but over a Bluetooth channel.
Okay.
The second is a connected mono type of application. This might be a walkie-talkie. This might be a very simple hearing aid. So a very simple single channel that has bidirectional communication. The third is a very obvious application, and that is true wireless stereo headphones or speakers. So this is a situation where you have 2 independent channels. The packet data has timestamps in it so that they can arrive in phase with low latency. And then the fourth application is probably one of the most interesting and still a bit of a challenge, and that is multi-channel connected audio. So conceivably you can have up to 32 channels of connected audio. Right now we're seeing kind of state-of-the-art 6 to 7 channels of connected audio, so say for a home theater type of system. Right. Eventually, with some larger processors and as the technology allows for it, you can have up to 30-ish, 32 channels of connected audio. So you could use that, say, in a language lab where you want to monitor students learning a foreign language. You could have this system, say, in public safety where you want a two-way communication with, say, up to 32 public safety officers. So right. A lot of interesting applications opening up with this flexible BLE audio.
Oh, wow.
Now, with regards to technical specifications, the LC3 codec is arguably a better codec compared to some of the, say, we'll call normal or standard classic Bluetooth audio codecs, but I have also talked to some folks at Qualcomm, and they are rolling out the, say, like their aptX HD, which has been very successful in classic Bluetooth, onto the BLE audio platform as well. So for niche high quality audio, there's going to be codecs available for customers as well. And then if you want to do like an apples to apples comparison between classic Bluetooth audio and BLE audio, you're going to see probably anywhere from 20% to 50% battery savings if you're running off a battery, depending on the settings for the application and the bandwidth that's being used. So very exciting protocol. We kind of are in a wait and see mode to see how it gets rolled out. I don't think classic Bluetooth is going to go away. I was joking with some folks today that in 1987, I quit buying LP records and started buying CDs. And here this last year, I started buying my daughter LP records again. So I think, classic Bluetooth has an install base that's not going to go away. It's going to be around for a long time. And I would say probably in the next anywhere from 3 to 5 years, we may end up getting like 33%, 50% market share with BLE audio. Right. But that may not be like general public. It may be like in specialty audio applications. Another interesting application for BLE audio is also for diagnostics. And so whether that's monitoring large generators in a plant, whether that's monitoring motors in an elevator, monitoring vehicle diagnostics for troubleshooting engines. There's a lot of interesting audio diagnostics that BLE audio also allows for.
Yeah, okay. Very nice. I mean, that I think is another exciting area that's going to be a lot of fun to watch, and we'll see how the adoption goes. It's always neat when a new standard comes out to see, how we get that full-on adoption of it. So obviously, we've talked about all these products, and Panasonic has such a wide offering in this wireless space. But there are a lot of other players, when we're talking about this kind of wireless application. From your perspective, why Panasonic? If I'm an engineer starting a new design, where do you guys think you guys have a particular strength in wireless, and why should you be considered for the engineer's designs?
Thank you. So Panasonic is known for having a very strong supply chain, known for high quality. I think one of the differentiators I would say is support and relationship. I still have enough bandwidth to talk to customers on a day-to-day basis. I travel almost weekly now, visiting customers and going to workshops and providing trainings. It's one of my favorite parts of my job, is putting together workshops and doing training episodes. But I would say probably one of the biggest differentiators is our partnerships with these special use case or application solutions. And again, Wirepass and Symbiotech for the mesh networking, IOC for asset tracking, and cloud to ground for BLE audio.
Right, right. I think just, the wide range of applications that you're working on, that's a lot of expertise that you can bring to a customer engineer that's starting a new design. I think beyond that, I mean, you mentioned Nordic and a lot of the radios that you have with Nordic chipsets on them, but you have a lot of other chipsets across that as well, so you're not beholden to any one single chipset and have a lot of different options to get the pros and cons of all the different chipsets out there. I think it's definitely a huge benefit that Panasonic has to offer. So.
We do have significant relationships with NXP as well, and NXP is definitely a leader in BLE audio. I've attended some workshops with them and been very impressed with their offering as well. Our NXP portfolio mainly consists of combo devices, so Wi-Fi, classic Bluetooth, and BLE chipsets that work in the IMX environment and with Linux and RTOS. And so typically these are higher end, higher performing types of applications, so medical, critical infrastructure, different industrial devices where you really need that power. So we're proud of our relationships with Nordic and with NXP as well.
Absolutely, absolutely. No, thank you very much, Matt. I really appreciate you taking the time to discuss some of this with us today. I think we can get very myopic when we're talking about wireless and just think about the communication side, but that's really just continues to evolve so much in so many new ways, and it's going to be fun, like I say, to continue to watch how that goes over the coming years. Thanks very much to our viewers. Really, really appreciate your time. Thanks so much for joining us on The Current. If you have wireless needs, if there's an application that you're looking for, whether that be a new BLE application, trying to implement AOA or AOD and being able to locate asset, or just trying to do a mesh network or general communication overall with wireless, we at Future Electronics absolutely love to help you with our engineers, with our partner engineers like those at Panasonic. Please feel free to reach out to us at Shaping the Future, one word, Shaping the Future at futureelectronics.com. And we would be happy to make some introductions or have some of our local engineers meet with you and make recommendations and support you in any way that we can. Thanks so much for joining us on this episode of The Current, and we'll look forward to seeing you next time.